This video is about logical shifts performing division. So I've got arithmetic shifts here as well, because both logical shifts and arithmetic shifts perform the same sort of function. What do they allow you to do? Well, they allow you to take a binary number, for example 1, 0, 0, 0, and in this case divide. I mean, you can multiply as well, but I'm going to talk about divide. And divide by powers of 2. So these are all numbers that are powers of 2. So that's 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, and so on. Okay, so 2 times 2 is 4, 2 times 2 times 2 is 8, and so on. So logical shifts and arithmetic shifts allow you to take a binary number, perform either multiplication or in this case division, allows you to divide them by powers of 2. Why would you have two systems that allow you to multiply a binary number by numbers that are power to 2? Well, the only difference is that logical shifts work with unsigned numbers and arithmetic shifts work with signed numbers. So this video is only going to talk about logical shifts performing division, and here's how it works. If you've already watched, which you should have, the video about logical shifts multiplication, then hopefully this will be really straightforward. If you haven't, then I suggest you go back and watch the multiplication one now. So for example, let's say I want to divide this binary number by, let's say 2 to the 1. So I write my binary number out. This number tells me the shift. It's saying shift it by 1. Well, shift it by 1 by where? The division is telling me to shift it by 1 to the right. So this goes here, and everything moves 1 to the right. And that's it. So this is the binary for 8. 8 divided by 2 to the 1. 2 to the 1 is 2. 8 divided by 2, well, that should be equal to 4. And this, yep, that's the binary for 4. Let's try another one. Let's say it's 2 to the 2, which is 4. And I write out my binary again. So what am I doing? I'm doing 8 divided by 2 to the 2, which is 4. 8 divided by 4. How many shifts? 2 shifts. 1, 2. So that's where my 1 drops. So 8 divided by 4 is 2. And that's it. That's how you do a logical shift with division. There's a couple of rules here now. Let's say I want to do 8 divided by, well, let's make it more interesting. Let's go with 12. Let's go with 15. 15 divided by 2, which is 2 to the 1. And I should really write out the binary. There we go. So 15 divided by 2. Divided by 2. So what happens? Well, it's only a shift of 1. So everything shifts that way. And if that's the case, then we lose that particular place, and it gets filled in with a 0. Well, what's the answer? 15 divided by 2 has given us the answer of 4, 5, 6, 7, which is not exactly correct. We've lost a bit of precision there. So this division is not like a maths division, it's more of an integer division, okay? So one of the rules now is when you're dividing certainly an even number, you will get an imprecise answer. It is the effect of performing an integer division, not a real division, but an integer. And if you don't know the difference between these numbers, you need to look at my other video about that. And that's it. That's how you perform a logical shift division. Okay, so have a go at these. Okay, so have a go at these. Let's go with 0, 1, 1, 0, 0, 1, 1, 0 divided by 2 to the 1. 1100000 divided by, let's go with 16, and 0110100 divided by, let's go with 8. Okay, so have a go at those. Press pause. Here come the answers. Okay, so dividing this binary number by 2 to the 1 means a right shift of one place. So this one goes there, this one goes there, this one goes there, and this one goes there, and then you fill in the zeros. 16, let's see, 16 is 2 to the power of 2 times 2 is 4, times 2, 8, times 2 is 16, so 2 to the power of 4. There we go, because there's 4 2's there, which means a shift of how many? 4. So we shift this one, 1, 2, 3, 4, 1, 2, 3, 4, and then we fill in the zeros. And finally 8, so that would be 2 to the 3, 2 times 2 is 4, 2 4s are 8, so 2 to 3, which means a shift of how many? Shift of 3. So we'll shift this one, 1, 2, 3, 1, 2, 3, 1, 2, 3, and then we fill in the zeros. And there we go. So we can quite easily check all of these now. So this blue one at the top is the binary for 102. 102 divided by 2 to 1, which is 2. 102 divided by 2 is 51, and that's the binary for 51. This next one is the binary for 192 divided by 16, which gives you the binary of 12 there. And the last one is 104 divided by 8, which gives you 13. Now, the one thing to look out for is that none of these gave us a integer division where you get an imprecise answer, but that's the final rule to look out for, that it is possible that a 1 could drop off the end and give you an integer division where the answer is not a decimal but a whole number.